You have to do in nodal analysis, you should have all parameters in terms of current. That's why I am transforming this voltage source into current source. A voltage in series with the resistance can be transformed as current source in parallel with the same resistance. Now I am redrawing the same circuit. In between this point I have removed, I have converted this as current source and I am redrawing now. In between the same point I have redrawing. Actual analysis will start from this point only. Six ohm, 2 ohm, 1 ohm, 5 ampere, 2 ohm, 5 ohm, 1 ampere, 10 volts. Okay. Okay. How many junctions here? In nodal analysis, you have to find the junctions. See, these 2 points are directly connected with these 2 points. Both are parallel. So this is path, and these 2 points is directly connected with these 3 points. These are all parallel. Simple. Actually, this point and this point. In between these 2 points, these 3 are connected in parallel. That means what I am trying to tell you, see this is one point, this is one point. In between this point, this 1 ampere also existing, this 10 ohm also existing, this 5 ohm also existing. 5 ohm, 10 ohm, 1 ampere. So these points, these 3 points are same points. Can you recognize now? Okay. So this is a junction V1, and coming to this point, in this point also there are 4 elements are connected. So this is a junction, and coming to this point 3 elements are connected. More than 2 elements connected means that is a node. So I am naming it as V3. And coming here, in this point, this is a single point, but it is having 3, 4, 5, 6 elements. So this is also a junction. I am taking it as reference. Reference means what? This V1 is with respect to this point, this is V1. With respect to this point, this is V2. With respect to this point, this is V3. So totally we are having 3 voltages. Now in each junction I am going to apply Kirchhoff's current law. In this junction, what are all incoming, what are all outgoing? Current source will deliver power. It will go towards the junction. This is junction, it will go towards junction. Source will go towards, loads will go away. These are all loads. Loads will go away. Any doubt? Because current means it should have direction. Sources will come inwards, loads will come outwards. Okay. Now come to V2. This is the source, it will come inwards. All others are loads, go outwards. And coming to V3, all are loads, so all will go away. All currents will go away. Simple. First step is marking. Okay, then at node 1 you write the equation at node 1. At node V1 you can give your own name. At node V1, by Kirchhoff's voltage law, by Kirchhoff's current law, incoming current is equal to outgoing current. What is incoming current? 1 ampere. I am keeping at a side. Outgoing currents, these 4 currents are outgoing current. This resistance is connected between V1 and 0. So what is the voltage across this so what is the current through this 10 ohm pa? I equal to V by R. V is V1 minus 0 divided by 10. V1 minus 0 divided by 10. This is the current through this 10 ohm. And what about this 5 ohm pa? It is connected between V1 and 0. So V1 by 5. And coming to this 3 ohm, it is connected between V1 and V2. So voltage is V1 minus V2 divided by corresponding resistance 3 plus. Coming to this 2 ohm, this is connected between V1 and V2, corresponding resistance is 2 ohm. So these are all the currents in that node 1. I have written all outgoing currents in one side, incoming current at another side. Any doubt ba? This is the forming of equation. Now I am consolidating coefficients of V1 1 by 10 plus 1 by 5 plus 1 by 3 plus 1 by 2. These are all the coefficients of V1. And coming to V2, you take minus V2 as common. So when you are taking minus V2 as common, 1 by 3 and 1 by 2 will be inside. There is no V3 here, so you write 0 V3 equal to 1. And if you are calculating in calculator, it will give 0.967 V1, 0.967 V1 minus 0.667 V2 plus 0 V3 equal to 1. This is equation 1. Now you try to tell me the equation at node V2 ba, at least at node V2 by Kirchhoff's current law. You tell me the equation now. This is the junction. Only incoming is 5 ampere. I am keeping at right hand side. Simple. And what about incoming currents? Incoming I have kept right side. What about outgoing currents? So coming to these 3 ohm, this 3 ohm is connected between V2 and V1. So V2 minus V1 is the potential across this 3 ohm divided by corresponding resistance. I equal to V by R pa. This formula I am applying, okay. And coming to 2 ohms, it is connected between V2 and V1 divided by 2 plus. And coming to 2 ohms, it is connected between V2 and V3 divided by 2. That's all. Only 3 elements. And I have found 3 currents. And now consolidate minus V1 1 by 3 plus 1 by 2 plus V2 1 by 3 plus 1 by 2 plus 1 by 2 minus V3 by 2 equal to 5. Any doubt ba? Can you write this equation? And coming to node V3, at node V3 there is no incoming current because no source. So right hand side it will become 0. Right hand side it will become 0. Left hand side there are 3 elements connected. You try to solve. This 2 ohm is connected between V3 and V2. So V3 minus V2 divided by corresponding resistance. So I am writing equation for 2 ohms ba, it is connected between V3 and V2, V3 minus V2 divided by 2. Coming to this 1 ohm, it is connected between V3 and 0. So V3 by 1 plus. Coming to this 6 ohm, where it is connected by V3 and 0. So V3 minus 0 divided by 6. Now you consolidate 0 V1 minus V2 into 1 by 2 plus V3 into 1 by 3 plus 1 plus 1 by 6 equal to 0. Now if you solve with the help of your calculator, you will get 0 V1 minus 0.5 V2 plus 1.667 V3 equal to 0. This is equation 3, and for equation 2 also, if you solve the inside components, it will give. Okay, I am directly writing the matrix. 0.967 minus 0.667 0. Second equation 0.66 minus 0.667 1.167 minus 0.5 0 minus 0.5 1.667. So these are all the unknowns, V1 and V2 and V3. Okay. So right hand side you are having 1 5 0 1 5 0. If you can solve in calculator, finally you will get V1, V2 and V3. These are all the node voltages. You try to verify at least 10.21. So after finding the node voltages, you can find any current. What is the current through this 10 ohm? What is the current through this 10 ohm? V1 by 10. You are having V1 now. What is the current in 1 ohm? V3 by 1. What is the current through this 2 ohm? V3 minus 2 or V2 minus 1 divided by 2. So with the help of these three voltages, you can find current anywhere. So when you know the current and voltage, you can get the power.